Hey guys, welcome to this video lecture series on the subject of energy technology. I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJIET Institute of Engineering and Technology. In previous video, we have understand the selection criteria for the refractories and we have seen the waste heat recovery part for the chapter of energy efficiency in thermal utilities. If you have missed that video, you can find that in the I button over here. Well, we have classified different waste heat recovery systems based on the temperature range involved. Now, in this video, we are going to understand different devices that are used for waste heat recovery. So, let's get started with commercially viable waste heat recovery devices. Well, there are different type of devices that can be utilized for the recovery of waste heat. The most known and very useful device is the recuperators. So, in a recuperators, heat exchange take place between the flue gases and the air through the metallic or ceramic wall. So, basically this kind of device is being made up of ceramic or metallic plate which essentially exchange heat. So, the duct and tube of these recuperators are carrying the air from the combustion to be preheated and other side contains waste heat stream. So, basically there are two sides of wall in such kind of system. On the one side, they carry air that need to be preheat for some useful purpose such as combustion. And on the other side, they carry hot fluid such as waste heat from the plant. So what we are going to do is, we will have such waste heat at a low pressure that we can utilize to heat up the air for the purpose of combustion. So here in the image, you can see the typical diagram of such recuperators, in which you can see that the air that need to be preheated is inserted from the top of the device and this air leaves from the bottom, while the hot fluid that is at the low pressure such as steam is entered from this side and leaves to the other side. So that heat exchange between these two fluids take place and the air it getted preheated. Well, there are different type of recuperators. The basic and simplest configuration of such device is the metallic radiation recuperators, which basically consist of two concentric metal tubes. Here in the image on the top of the screen, you can see that there are two cylindrical tubes which are concentrated and you can see that both carrying different fluids. The inner tube consists of hot exhaust gas while the external annular space carrying combustion air for the atmosphere that has to be fed to the furnace. So, the inner tube that is shown by the red and yellow color is nothing but the hot fluid such as low pressure steam. While the annular space between these two cylinders, you can see in this image, is being filled by air that need to be preheated for the combustion purpose. The hot gases are cooled by incoming air, thus the air now carried additional heat energy into the combustion. So what will happen is, this hot gases transfer its heat to the air and this air will be preheated by exchanging heat from these hot fluids that ultimately reduced energy for the combustor. This is the energy which does not have to be supplied by fuel and consequently less fuel is burned for the given furnace load. So, by means of recuperators, we can achieve significant amount of energy efficiency and we can reduce the consumption of fuel, since the energy required for preheating the air will no longer required with such application. So, this was all about the recuperators that used for waste heat recovery systems. Now, let's understand the second type of the device which is majorly used in industry, and that is regenerator. Well, the regenerator of heat which is preferably for a large capacity, are widely used in glass and steel melting furnace. So, such kind of regenerator are widely used in the industry, particularly industry involved glass and steel melting, so that we can recover large amount of heat. Size of regenerator, time between reversal, thickness of brick and conductivity of brick, and the heat storage are some of the important parameters that are considered for the regenerator. So basically performance of this regenerator mainly depend on thickness of brick or the conductivity of brick and size of this regenerator. In regenerator, time between reversal is important aspect. Long period would mean higher thermal storage and hence higher cost. So, long time of operation means the large amount of heat need to be stored and that ultimately increase the storage cost. So, the shorter time of reversal is required for the regenerator. Accumulation of dust slagging on the surface reduce the efficiency of heat exchanger and ultimately reduce the efficiency of furnace. So, as furnace become old and that is being used in very long time, their efficiency is being reduced because of some formation or accumulation of dust and slagging on the surface of heat exchanger. Here on the top of the screen you can see the typical image of the regenerator. Now let's understand the third type of the device, and that is heat wheels. Heat wheel is finding its increasing application in low and medium temperature waste heat recovery systems. It is porous disc fabricated with material having a fairly high heat capacity which rotates between two slices by side ducts. One is cold gas and on the another side hot gases duct are there. So basically you can see on the image the diagram for the heat wheels. It is being made up of two different ducts that are utilized for the hot fluid and for the cold fluid. One side of this duct carries the cold fluid and on the another side the hot fluid such as waste steam or low pressure steam is being carried out. So this steam rotate the wheel and transfer this heat to the colder fluid such as air that need to be preheated. The axial rotation is parallel and on the partition between the two ducts. So here in the image you can see that the axial rotation of this wheel is on the partition and it is parallel to the duct. As the disc rotates, the sensible heat is transferred to the cold air from the hot gases. So as soon as this wheel will rotate, it will transfer the sensible heat of this steam or waste heat towards the air or the colder fluid. The overall efficiency of heat transfer by such regenerator is high as 85%. So we can utilize this kind of device for heat recovery. Its efficiency is around 85% and they are basically used for low to medium temperature ranges. Now let's discuss the fourth type of this waste heat recovery device, and that is heat pipe. Well, the heat pipe can transfer up to 100 times more thermal energy than can be copper. The heat pipe is the thermal energy absorbing and transferring system and have no moving part, hence is require minimal maintenance. So here in the image you can see that one heat pipe system is shown that basically contains no moving part. Hence it is understandable that it will require minimum maintenance. While such kind of device are containing energy absorbing and energy transfer materials. The heat pipe is made up of capillary wick, container and working fluid. So basically there are three main components of such heat pipe. One is capillary wick, the container and the working fluid. Thermal energy applied at the external surface causes the working fluid near to surface to evaporate. So what will happen is the waste heat such as low pressure steam will transfer its heat to the external surface of this pipe. Here in the image you can see that the top of the surface of this heat plate is receiving heat energy from the steam. This heat energy causes the fluid or the working fluid inside the pipe to evaporate. The vapor thus form absorb the heat and then travel to the another end, and this heat can be removed by condensation. So when the heat is required to extract from such kind of devices, it is condensed at the another end of the pipe. So it was all about the different waste heat recovery devices. So this concludes the chapter of energy efficiency in thermal utilities. Let's summarize all the things that we have covered in this chapter. Well, we have started this chapter by saying that it contains in a 4 part. First is the fuel and combustion. The second one is steam system. The third one is insulation and refractories. And the last one is the waste heat recovery. So in the fuel and combustion, we have studied different properties of fuel such as calorific value, flash point, specific heat and viscosity. For the exam point of view, these properties are very important. They can ask different property for 1 marks question, and combinedly they can ask 3 to 5 definition for the 3 to 5 marks question. Then we have seen the preparation of coal, in which we have seen the sizing of coal, conditioning and blending of coal. And we have seen the principle behind combustion. So again, this preparation of coal is very important for the exam point of view. Then we have seen the proximate and ultimate analysis, in which we have seen the measurement of moisture, volatile matter, carbon and ash content in the proximate analysis. While in the ultimate analysis, we have seen the total content of carbon, hydrogen, sulfur and nitrogen. Then we have moved to the steam system and understand different properties of steam such as enthalpy, quality of steam, and then we have seen the steam distribution. Then we have understand the leakage and trapping system for the steam, such as the thermostatic and mechanical trap systems. These two are again important for the exam. Then we have moved to the third point, and that is insulation and refractories, in which we have seen different type of insulation based on the temperature range involved. Then we have seen the economical thickness of insulation, which is again extremely important for the university exam. Then we have seen type of refractories and selection of refractories, and concludes this chapter with heat losses through refractories. And in today's lecture, we have seen the waste heat recovery and classification of waste heat recovery and economical viable waste heat recovery systems such as recuperators, regenerator, heat wheel and heat pipes. So this concludes the entire chapter of energy efficiency in thermal utilities. We will see you in next video. Till then, keep watching, keep learning. Thank you.